so we're looking at like equations, and we're trying to find where equations sort of equal each other or where they're part of each other, okay? So we're still going to be graphing them, and we're going to use the graphs to answer the question. The only tricky thing is sometimes that the graphs are so, they kind of bunch up together, and you have to scroll in and out a little bit to find it, so that's kind of tricky. On this one, I just wanted to show you how this works. If I put the 10 where the y goes, I get 1/5 times 10, that equals 2, and that's what x is. So I just wanted to show you with numbers that it works, that you could take like a fraction of a number to get another number. With polynomials, it's similar, except you're trying to find a fraction of an equation, okay? So what we're going to do to solve number 2 is we're going to put, it says 1/6 and then f of x, and then it says g of x. So g of x is going to be one thing we put in the Desmos. And the other thing we put in the Desmos is going to be 1/6 and then f of x, okay? But we're not going to put actually f of x. We're going to put like what the equation is. I'm going to move it over just a little bit so you can see it when I start typing. But, so you're going to put 1/6, and then you're going to put a parentheses because you're going to put what f of x is in there. Okay, and then you're going to also put g of x as another thing. And the graph's going to be really strange, okay? And a lot of times you're going to be looking for 3 answers. I think the work that you'll be seeing, there'll be 3 answers. There's not always 3 answers, but there will be on this particular problem. And so you're looking where the blue and the black lines cross. I can tell they cross somewhere around in there. So sort of click, and you'll see some points that pop up. So one of my answers is -1. Okay? Now I'm going to be looking, and I'm going to kind of scroll a little bit, or I'm going to move it around, and I'm trying to see where the blue and the black cross again. So that it looks like the blue and the black cross somewhere down in here, and when you click on it, something will pop up. Oh, 3 is another answer. So we got -1 and 3, and I do feel like there's another answer somewhere. And you can just kind of click and see. I don't see anything that came up yet. But maybe down in here somewhere. I don't see anything there. I'm going to make this a little bit bigger so it's easier to tell. And this is not really the only hard part of this work, is like having to scroll a little bit. There's somewhere around in here, but I think maybe that's the one we already got. Oh, we didn't get that one. That was 4. And you just kind of have to keep scrolling around till you can tell if that's going to give you the answer or not. That's kind of tricky, but that's what you're looking for. Okay? So let's look at number 2. I'll make that small again, and let's look at, or number 3. So we're going to put 12x plus 48 into one thing, and we're going to put 1/3 and then f of x in the other thing. So we'll put 1/3 and then 3x to the 3rd plus 12x squared minus 24x in one thing, and then 12x plus 48 in another thing. And again, I'm going to make it bigger just so that we can see it. And we're just looking for where these two things cross. And sometimes it might look really weird, so maybe if you press home, you can see it a little bit better. So it's this blue line right here, and we're trying to intersect it with the black one. So somewhere down in here it's going to intersect. So -6 is one of the answers. And then it's going to intersect somewhere else back up in here. There's another answer, -6, -2. And then I'm going to scroll one more time just to see, and I'm thinking that the blue and the black is going to intersect up here somewhere. -6, 2, and 4. It does not matter what order that you put them in as long as you have all the answers. And if you know, like if you're looking at multiple choice and trying to figure it out, you can just kind of like scroll to that number if you wanted to. You can also make this a table in case it's helpful for you. If you go to that little thing right there and press table, and if I do the same thing on the other one, if I can get there, it's possible that if it's helpful that you could look at this to see where they have the same y values, like I can tell that -2 and -2 are the same. That's another way to check, but I think the graph's easiest if you move back and forth with the graph. Okay? Alright, one other thing I want to show you, so I'm going to skip on down to these problems at the bottom. There's something called maxes and mins of a polynomial. Okay? And when you're looking at this, like the graph keeps going forever, up, up. But in the middle of the graph, there's things that have like, there's mountains and there's valleys. If it's a mountain, it's a maximum. If it's like a valley, it's a minimum. Okay? So I would say that this value down here is a minimum. This value up here is a maximum. This value is a minimum. And if I said, what is the minimum? Then you would tell me the y value. Okay? So the minimum here is whatever the y value is, it's -4, so -4 is my answer there. The minimum here is whatever the y value is, so it's -1 on that one. And then the maximum here is 2, and so not 2, because that's the x value. I got to talk about the y value. So the maximum is 0, because that's where it is on the x-axis. On number 7, what's going on with this one? Max or min? Max. And I'm not exactly sure what it's supposed to be. We're going to say like maybe 1.5 or 2. We'll just say 2. But you'll be able to use Desmos to figure out the point exactly. And then this one down here is a min. And we're going to say -2 maybe. Alright, and then the question here says, compare the maximums of f of x and g of x. Which one has a bigger maximum? Okay, so what it wants me to do is it wants me to graph these two and figure out which one, like as the maximum, is bigger. Okay, so again, we're going to Desmos and we're going to graph that. So we have -x⁻³ plus 2x minus 1. And we also have x⁻³ plus 4x, I think that's squared, plus 4. I'm going to hit home to make it easier. Okay, look at the green. This one has a maximum up here, right? That's a maximum. Alright, and now look at the blue. There's the maximum. Which one of those is bigger? The green. So the green is the second one, g of x. So g of x is bigger.
Wait, what good? It's a number.
It doesn't matter. When we look at the values, we're looking at how tall they are. And the green one is taller. To figure out what it actually is, if it said, well, what is the biggest maximum? Then you just write down the y value. So the y value that's the biggest is 13.747, or 474. If it says what's the actual maximum. Okay? It's always the y value. You never look at the x value. Okay? Alright, let's look at the last one. x⁻⁴. And then -2x⁻³ plus 3x. Okay. So here, the purple, the minimum is way down here at the bottom because it just has like a minimum at the bottom. The black one has a minimum down here. And it asks you which one has a lower minimum. So which one of those is lower? The purple or the black? The black one. And the black one is this one, so still g of x. And if it said, well, what is the lower minimum? It's that y value that we see, which is negative 1.414.